Hi, my name's Michael Chow, and I work on the data science team at Datacamp. Previously, you learned about the data science workflow. In this lesson, we'll focus on the first step, data collection. Data is everywhere, and almost any business process can generate mountains of data. Some of the most common sources of data are web events, customer data, logistics data, and financial transactions. It's possible that your company is already collecting all of this information. It's best to ask your data engineers what is collected and what isn't, and to emphasize the importance of starting the centralized data collections process sooner rather than later. Let's dive a bit deeper into web data. When a user visits a web page or clicks on a link, it can be helpful to track this information in order to calculate conversion rates or monitor the popularity of different pieces of content. At a minimum, you'll want to collect the name of the event, which could mean the URL of the page visited or an identifier for the element that was clicked, the timestamp of the event, and an identifier for the user that performed the action. Suppose Jane Doe is a customer who visits your company website and likes one of your products. You might choose to track her name, the timestamp, and the object that she clicked on. It's important to remember that Jane Doe's name is personally identifiable information, or PII. PII includes a person's name, location, email address, and any other piece of information that could be used to tie a web event back to a real human. PII should be treated with extreme sensitivity and caution. One of the easiest ways to protect Jane's identity is to split this information into two separate entries. We can assign Jane a user ID, in this case 185477, and store that information in a users table. We can then identify her event using this ID. We call the data in the events table pseudonymized because Jane can't be identified by that table alone, but she can be identified if we combine information from the users table with the events table. To protect Jane, we'll want to make sure that access to the users table is restricted to only folks who need to know Jane's identity, such as senior customer service representatives or members of the legal team. We'll also want to periodically audit who has accessed this data and how they have used it to ensure that Jane's data is respected. The best way to protect Jane's privacy is to destroy the information in the users table after assigning Jane's user ID. Without the users table, the events table is fully anonymized data. For many analysis purposes, anonymized data is sufficient. We need to know that Jane is a unique individual, but we don't need to know her name or any other PII. You might have heard the term GDPR from your data team recently. GDPR stands for General Data Protection Regulation and applies to all data inside of the European Union. The purpose of GDPR is to give individuals control over their personal data. Among other things, GDPR regulates how long data can be stored, mandates appropriate anonymization, and requires data collection to be disclosed and consent to be obtained. It's always best to consult a lawyer when dealing with any data inside of the EU to ensure that you comply with GDPR. You now know some common sources of data, the difference between anonymization and pseudonymization, and the definition of GDPR. Let's practice. In the last lesson, we learned about data that your company can collect through the web or financial transactions. Now, we'll cover data that you can obtain by asking your customers for their opinions, which we'll call solicited data. Solicited data can be used to create marketing collateral, such as a post about what % of our customers are satisfied with our product. It can also be used to de-risk a decision-making process, such as when we survey users to gauge interest in a new product. Finally, it can be used to monitor quality, such as when Datacamp asks users to rate each course. Common types of solicited data include surveys, customer reviews, in-app questionnaires, and focus groups. This image shows a very common type of solicited feedback, the Net Promoter Score, or NPS, which asks how likely a user is to recommend a product to a friend or colleague. Solicited data can be qualitative, such as conversations and open-ended questions, or quantitative, such as multiple-choice questions or rating scales. Qualitative data is very subjective and requires a lot of analysis. Quantitative data can be easily summarized in a graph or chart. In general, collection of small-scale qualitative data is good for generating hypotheses. For example, a focus group might provide some ideas about what features we might want to build. Larger-scale quantitative collection is needed to validate these hypotheses. For example, we can ask users to rank a list of features from most desirable to least desirable. It's important to remember that solicited data generally tells us our users' stated preferences. A stated preference is what someone tells us they want or believe, and is somewhat hypothetical. When a user actually takes an action, such as purchasing a product, we learn their revealed preference. We hope that our users' stated preferences are good indicators of their revealed preference, but this isn't always the case. Many people have a stated preference to go to the gym frequently. However, many of the same people's revealed preference is only to go occasionally. Some gyms have an entire business model based off of the expected difference between people's stated and revealed preference for exercise. Now that we know some types of solicited data and are aware of the pitfalls of revealed versus stated preference, let's go over some best practices. First, we should try to be as specific as possible when asking questions. This specificity should apply to both the wording of the question and the potential answer choices that we give. Next, we should avoid loaded language, especially if it might bias respondents toward a particular choice. For example, avoid using adjectives to describe possible choices and try to be objective. Whenever possible, calibrate your survey by comparing to known quantities. For example, rather than asking a respondent if they are interested in a new product, ask them to compare their interest in that product to their interest in one of your current offerings, or the offerings of a known competitor. Finally, it can be tempting to ask as many questions as possible. Fight that instinct and instead ensure that every question you ask will help you take a decisive action. For example, if customers indicated a preference for feature A over feature B, you should commit to building feature A first. You've learned about uses for solicited data, types of solicited data, and the dangers of revealed versus stated preference, and some best practices for designing questions. Let's practice. While collecting internal data is useful for some data science projects, it's only one piece of the puzzle. Often, you need to gather data from external sources as well. There are many ways that you can collect additional data for your organization. A few common ways include APIs, public records, and Mechanical Turk, all of which we'll discuss in this lesson. Let's begin with APIs. API stands for Application Programming Interface. It's an easy way of requesting data from a third party over the internet. Many companies have APIs to let your team access their data. Some notable APIs include Twitter, Wikipedia, Yahoo Finance, and Google Maps. But there are many, many more. If you work with a partner and think that they might have useful data, do a quick web search and see if an API exists. Let's look at an example of the Twitter API. Suppose we want to track tweets with the hashtag DataFramed, Datacamp's wonderful podcast on data science. We can use the Twitter API to request all tweets with this hashtag. At this point, we have many options for analysis. We could perform a sentiment analysis on the text of each tweet and get an idea of how people like our podcast. We could simply track how often hashtag DataFramed appears each week. We could also combine this data with our downloads data and see if positive tweets are correlated with more downloads. Public records are another great way of gathering additional data. In the US, data.gov has health, education, and commerce data available for free download. In the EU, data.europa.eu has similar data. These can be great sources for understanding population-level trends or gathering location and economic data. Previously, we discussed image recognition as a type of data science problem. In order to build a good image recognition algorithm, we need a set of pictures where the images have already been labeled, which is called our training set. But we don't need just one or two pictures. We need hundreds or thousands of pictures. Getting these labeled images can be really difficult and time-consuming, and a lack of a training set is often what keeps good data science projects from being completed. Depending on what kind of training set is needed, Mechanical Turk, also called mTurk, can be a great option. Mechanical Turk means asking humans to complete a task that we eventually plan on computerizing. In our previous example, this would mean labeling a handful of pictures to create a training set for image recognition. Rather than asking one person to label thousands of images, we recruit thousands of people and pay each of them to label a few images. To ensure quality, we might ask 2 or 3 people to review the same image and then take the most common answer. Many platforms exist to help build your Mechanical Turk problem and recruit helpers, such as AWS mTurk. Mechanical Turk isn't just for image recognition. You can also use it to label customer reviews as positive or negative, extract text from a form, or highlight keywords in a sentence. In the example on the right, users are asked to identify which sections of the image contain a street sign. You now know about 3 ways of getting external data: APIs, public records, and Mechanical Turk. Let's practice. In the previous lesson, you learned about many sources of data. Now, let's discuss efficient ways of storing the data that your organization might collect. Your business probably generates far more data than could even be stored on a single computer. In order to make sure that all data is saved and easy to access, you'll want to store it across many different computers. Your company might have your own set of storage computers, called a cluster or a server, on premises. Alternatively, your company might pay another company to store data for you. This is referred to as cloud storage. Common cloud storage providers include Microsoft Azure, Amazon Web Services or AWS, and Google Cloud. These services provide more than just data storage. They can also help your organization with data analytics, machine learning, and deep learning. For now, we'll just focus on data storage. Different types of data require different storage solutions. Some data is unstructured, like email, text, video and audio files, web pages, and social media messages. This type of data is often stored in a type of database called a document database. More commonly, data can be expressed as tables of information, like what you might find in a spreadsheet. A database that stores information in tables is called a relational database. Both of these types of databases can be found on the cloud storage providers that were mentioned earlier. Once data has been stored in a document database or a relational database, we'll need to access it. At a basic level, we'll want to be able to request a specific piece of data, such as all of the images that were created on March 3rd, or all of the customer addresses in Montana. In addition, we might even want to do some analysis, such as summing, counting, or averaging data. Each type of database has its own query language. Document databases mainly use NoSQL, while relational databases mainly use SQL. SQL stands for Structured Query Language, and NoSQL stands for Not Only SQL. Storing your company's data is like building a library. First, you need to decide where to build your library. That corresponds to choosing a cloud, either an on-premises cluster or one of the providers we discussed before, Azure, AWS, or Google Cloud. Next, you need to decide what types of shelves to install to store your books. The types of shelves will depend on the types of books. This is analogous to choosing between a document database for unstructured data or a relational database for tabular data. Just like a library might have multiple types of shelves, you might need to have some data stored in a document database and other data stored in a relational database. Finally, you'll need a system for referencing and checking out books. The way you locate and retrieve each book depends on how that book is stored. Similarly, you need a query language to speak to the database. For document databases, we generally use NoSQL, and for relational databases, we generally use SQL. Now that you understand different ways of storing data, let's practice.